Okay, so I'm gonna test out the audio of this microphone. Here I've got it at, let's see, approximately a handspan distance from the microphone to my chin. And I need to see what it's gonna sound like if I go up close. Hello, hello. Okay, yes. Now, now what? Well, to really test it, I should just read for a minute. So, I'm just going to read aloud some chemistry notes. An atom comprises a nucleus and electrons. The nucleus is at the center and contains protons and neutrons, and the electrons orbit in energy levels or shells around the nucleus. The protons have a charge of +1 and a mass of 1, and the neutrons have a charge of 0 and a mass of 1. The atomic number of an atom, symbolized by Z, is the number of protons that it has. And so that makes sense as a name because it's literally telling you which atom it is. In a neutral atom, the atomic number is also equal to the number of electrons. That is to say, in a neutral atom, there are as many protons as there are electrons. The mass number of an atom, symbolized by A, is the number of protons plus the number of neutrons. Isotopes are atoms of the same element with the same atomic number, but with a different mass number. For example, carbon-12, carbon-13, and carbon-14 all have 6 protons, but a different number of neutrons. Okay, so that was just me reading out my notes just for a minute. Now, let me think about the sensitivity of this microphone. Okay, so the gain is like midway, so I'm going to turn it over here. And yeah, this is as far clockwise as it will go. So here's what my voice sounds like under this setting. And I'll just read out some notes, some further notes, and then I'll try the absolute opposite. Electron configuration is very important when thinking about atomic structure. Electrons fill the lowest energy levels first. They tend to, anyway. They fill the first shell with 2 electrons, then the second shell with 8 electrons, then the third shell with 8 electrons, and so on. For example, sodium, whose chemical symbol is Na, has an atomic number of 11, and the configuration of its electrons is 2, 8, 1. 2 in the first shell, 8 in the second shell, and 1 in the third shell. The third shell of sodium is referred to as the outer shell, and the electrons in that shell are called valence electrons, and they determine the chemical properties of sodium. And this is the case with all the atoms. Right, now I'm going to try the opposite setting. So this is as far anti-clockwise as I can turn it, and anti-clockwise when I'm directly looking at it.